Hey guys, Mr. McDonald here. Today we're going to talk about reflex arcs. All right. Reflex arcs are kind of like decision-making loops, only they are involuntary. As you can see in the slide here, it says that a reflex arc is a rapid, predictable, and involuntary response to stimuli, which is a little bit different than a decision-making loop. In a decision-making loop, we understood that there was a stimuli, and then we sat and based on previous experiences on our desired outcome. On the other things we see happening in our environment, we decided what we were going to do. It was a conscious decision. Reflex arcs are not like that. The outcome is already predetermined. So your body already knows when it experiences some type of stimulus, the outcome is going to be this. And because of that, it can structurally make a pathway that's going to make that electrical impulse go directly from the sensory input to the effector organ. All right, so that allows it for it to be rapid, predictable, and involuntary, much like the slide says here. All right, so again, our function is rapid, predictable, and involuntary. Our structure has to support that. So that's what we get into now. We get into the structure. Okay, so the structure are these neurological pathways called reflex arcs. And a reflex arc is a direct route from a sensory input to an effector organ. All right, it doesn't stop in the brain. Again, the brain's very indirect because we want to consciously make a decision. These decisions are already made for us. So let's check out a picture of one. All right, so here we see a nail that is stuck into the skin somewhere on the body. And as you guys learned last week, mechanoreceptors, specifically pain receptors, are going crazy right now because there's a nail stuck in your skin. And they're sending those electrical impulses through the sensory neuron, and we hit the spinal cord. Now, in a decision-making loop, that information would then move from the spinal cord up to the brain. But this is not a decision-making loop. This is a reflex arc. So now we have this little thing right here called an interneuron. Let's grab a marker here. All right, so the interneuron replaces the brain because the decision's been made. So in order to carry out that function structurally, we now have this interneuron that takes our electrical impulse directly to our predetermined desired outcome. Okay, and so our electricity moves directly from our sensory neuron to our motor neuron. Once it crosses the synapse from the interneuron to the motor neuron, it can now travel directly to the effector organ. And now we get our predetermined outcome. Okay, so again, the difference is here, they label it the integration center. Okay, so again, this is involuntary, predetermined, thus making it quicker and predictable. All right, so those are the two key differences. These are predictable, they're quick, and they're predetermined. All right, so let's move on here. Some examples from the body of reflex arc. They're somatic reflexes. All right, these involve skeletal muscles in some sort of way. All right, so the example they give you is that you'll pull your hand away from a hot object. So if the stove was hot and you put your hand on it, the heat receptors in your hand, again that we learned about last week, would go off and you would automatically pull your hand away. You don't need to think about it. You don't sit there and go, it's hot, I wonder what I should do. Your hand goes away. It's quick, it's fast, it's going to happen every single time. All right, so that's a somatic reflex. We also have autonomic reflexes. And a great example of literally hundreds of these is think about what happens when you eat your mac and cheese or your pierogies, man, or whatever you guys would have for lunch. After you consciously decide to swallow and your tongue pushes your food to the back of your mouth, the autonomic nervous system and autonomic reflexes take over. All the smooth muscle tissue that is found in your digestive system, in your esophagus, in your stomach, in your large intestine, small intestine, all the different sphincters that are there are all regulated by these autonomic reflex arcs. All right, so same thing with your circulatory system. All right, arteries, veins, cardiac muscle in your heart. that regulates your blood pressure. All those things are all autonomic reflexes and run on autonomic reflexes. All right, so again, we've discussed this quite a bit. The big difference here is in this bullet point right there. Let me put some stars here. All right. Bullet point 1, 2, 4, and 5 are very much the same as the decision-making loop. But this one is different, okay? Because the integration center is a direct route to your desired outcome. It's a direct route from the sensory neuron to the motor neuron. Literally, the interneuron would be that black arrow. There's no thinking about it. It's structurally direct. Okay, so again, that's what we got going down in our reflex arc. All right, so now we've talked about that already. We don't need to see that again. Last thing we got to hit here, guys, is we have two different types of reflex arcs. We have a 2-neuron reflex arc and a 3-neuron reflex arc. So let's check out the picture of the 2-neuron arc. Okay, so we see one right here, and this is the classic patellar knee-jerk reaction. So you guys have all seen this somewhere where the little rubber mallet hits you guys subpatellar and the leg kicks out. So what happens is there are GTOs, Golgi tendon organs, that are in the patellar tendon, which is right there. And once it senses that pressure, it creates an electrical impulse that travels. Let's see. Let's get the old marker back. Out to the spinal cord. Whoa! It's like a roller coaster. And now it goes directly through one synapse to the motor output. So this is different from what we did talk about. We talked about a 3-neuron loop before that had an interneuron right here. Okay, there is no interneuron in the 2-neuron loop. All right, the sensory neuron goes directly to the motor neuron. It's a little bit faster. It's just as predictable, but since there is no interneuron, again, there's one less synapse, and because of that, it makes it a little bit faster. Okay, so that is the 2-neuron reflex arc. Get rid of the marker. Okay, last but not least, we have 3-neuron reflex arcs, and what's different here is that there's an interneuron. All right, so the difference, let's do a different color this time. Let's go green. The difference now is the presence of the interneuron. Same thing, we have a thumbtack here, so we're about to experience pain. Sensory input, coming back, get to our spinal cord, and now we have 1, 2 synapses, so it's a little bit slower, okay, but the outcome's still the same. We have our interneuron. Hang on, let me blow my nose a second, guys. Which takes our electrical impulse directly to our motor neuron, and we get our output cruising along to, in this case, the biceps brachii, which pulls back the hand. And in the case of the thumbtack, we hopefully don't do much damage to our fingers. Okay, so that's what we got going down today. Just to review here quickly, the big difference here between decision-making loops and the different types of reflex arcs is what happens at the integration site. Okay, in the decision-making loop, we went to the brain, where we had voluntary thought processes that could lead to different outcomes here. And because of that, it's slower. Maybe there's never a reaction. Maybe the answer is to not react. Okay? Where in the reflex arc, we don't do that. We have a predetermined reaction that's structurally designed for us. So our electrical impulse goes through an interneuron or maybe directly to a motor or efferent neuron, and it goes back out. So that's our reflexes. All right, so hopefully that helps out. Again, the main idea was to be able to compare and contrast decision-making loops with reflex arcs. If you have any questions, please let me know. Otherwise, have a good day.